In this video, we'll discuss another design pattern that is very widely used in practice. In fact, when I started coding, the observer pattern was the first design pattern that I had encountered. In fact, I didn't even know it was a design pattern. It's present everywhere. If you worked with any kind of framework in any programming language, well, you've encountered the observer pattern. So, what exactly is this observer pattern? The observer pattern helps us implement a very important design principle, a principle that we discussed earlier on. This is the Hollywood principle, which says, don't call us, we'll call you. This is what high level objects will tell low level objects. But how will high level objects call low level objects? Well, they'll use the observer pattern. It's always the case that you have a higher level general purpose abstraction and then you have specific low level objects which deal with granular details. These low level objects need to know when the higher level object has changed in such a way. So they need to listen to changes on the high level objects. And this listening for changes or observing the high level object is what the observer pattern allows us to do. The observer pattern allows us to establish one-to-many dependencies between objects. You have a higher level abstraction that is a higher level module. When this higher level module changes, the low level modules should not be querying the high level module for changes. They should be notified immediately. So, in some ways, these low level modules depend on the high level modules. There might be many granular modules and one higher level abstraction. And this dependency can be set up using the observer pattern. The high level module will only have a list of recipients or dependents. It need not know the details of any dependent. All it knows is that the dependents have an interface and the high level module can then interact with the dependents using this interface. When this high level object or module changes state, it'll fire notifications. It'll basically tell every dependent that I've changed state in a particular way. Now, if this affects you, go ahead and handle it any which way you please. This is the observer pattern. The dependents are observers of the high level module. In summary, when would you choose to use the observer pattern? When you want to follow this principle of good design, the Hollywood principle. You don't want your high level objects to depend on low level objects. You want your low level objects to depend on high level objects. Low level objects should not be querying high level objects. Instead, they should be listening for changes on high level objects. High level objects will basically fire notifications or fire events to listeners or subscribers to their object. Here, the document and pages example serves very well. The document is a high level object, pages are low level objects. Pages listen for changes on documents. If the document itself has changed, maybe all of the margins of the documents have been reset to some new value, then all of the pages need to be updated as well. The document will notify all of the listening pages that something has changed and the page will update itself accordingly. So when the object changes states, all dependents are notified and updated automatically. And this is widely used because event handlers follow the observer pattern. If you've done any kind of UI, that is user interface programming, you've dealt with events. You have a button or a checkbox that everyone is listening on, and if something changes, the button notifies its listeners. This is an example of the observer pattern. In my opinion, the observer pattern is far more important in JavaScript as compared with other languages because JavaScript is used for writing client side code that interacts directly with the user. And once you have client side code, you have user interactions which have to be handled using events and event handlers. The entire event handling system in JavaScript is based on the observer pattern. The observer pattern is the cornerstone of event driven programming, a major focus of the JavaScript language. This event driven programming model that JavaScript implements using the observer pattern facilitates good object oriented design, which means you can have components which talk to one another, communicate with one another without depending on one another. The use of the observer pattern allows us to follow the principles of encapsulation, data hiding, and loose coupling, which are hallmarks of good object oriented design. The observer pattern helps decouple objects which trigger events from handlers which respond to events. The internal implementation of objects that fire events can change independent of event handlers. Only the interface of how event handlers listen in on events affect those who trigger events and those who listen in on events. This forms the contract. Let's take an example from the real world of how the observer pattern might work. Let's say you're attending an auction. You have an auctioneer who's responsible for setting up different items that you might bid on. Now, all of the bidders are observers. The auctioneer here is the subject or the higher level module. All of the bidders are constantly watching and observing the auctioneer. They want to know what item will come up for auction next, or what the current bid prices, what the current high bid prices, so that they can make their decisions as to whether to top this bid or not. Now, let's say the auctioneer accepts some high bid, which comes from bidder number 13. Once the bid is accepted, this becomes the new high price. The auctioneer then broadcasts or notifies all of the other observers of this new high price. This new high bid is then broadcast to the bidder observers. The bidder observers can then choose to react or not. Observe that the bidder observers are not querying the auctioneer for the bid information. It is the auctioneer's responsibility to notify the observers when something has changed. Let's now look at a high level architecture diagram of how the observer pattern might be implemented in your code. We have the subject here. This is the higher level module, the publisher that subscribers or observers are interested in listening in on. This subject has internal state that can change, and observers need to be notified of those changes. So you have a set state and get state function exposing the state of the subject. There is also a method for new observers to listen in, to attach themselves to this subject. That is the attach method here. In the real world, the subject can be thought of as a model which holds data, and changes in the data need to be notified to views who are interested in listening in on those changes. Anytime there is a change in the data associated with this model, all of the views that have attached themselves as observers will be iterated over and updated. This is the notification sent to views. Now, views which are observers have access to the subject and are interested in the state changes of the subject. Views are interested in the data that lies behind the model. Every interested view will register themselves as an observer of this subject, the model which holds or encapsulates the data. Anytime the data changes, the update method on the view is called. And within the update method of the view can access the current state of the model in order to update itself. This implementation of the observer pattern is a foundation of the model view controller paradigm, often used to build robust user interfaces. In this demo, we'll see an example of how we can implement the observer pattern in JavaScript. The observer pattern allows us to define a one-to-many dependency between objects, so that when the single important object changes state, this state change is sent as a notification to all other objects that are interested in learning about this object. The other objects that are interested in learning of state changes register themselves as observers. The HTML page for this first implementation of the observer pattern is very straightforward. All of the interesting stuff will be in observerpattern.js. Imagine that you have an object that represents an e-commerce site, and an e-commerce site has many products listed within it. I'll now set up an ES6 class to represent this e-commerce website. The constructor for this e-commerce site basically sets up the products that are listed here, and as an example, I'm going to take just 5 products. Let's imagine that these are products or product categories on this e commerce site: mobile phones, books, household items, dog food, and fashion. Now, this may seem rather limited, but this will serve for our example here. Now, the different customers in our e commerce site will be interested in different categories of products. Some might be interested in books, some in dog food, and others might be interested in the fashion category. There might also be customers that are interested in more than one category. Within this constructor, we instantiate an observer map, which is just a JavaScript object that can hold key value pairs. The observer map is so called because it will hold a mapping of product categories and the customers of this e commerce site who are interested in those product categories. Interested customers will receive notifications for product updates when things are back in stock, when new items are on sale, etc., for that category. Initially, of course, when we first construct the e commerce site, there will be no observers for each category. So we'll set the values for each product category to be an empty list of observers. This we'll do using a for loop for I equal to 0, I is less than this dot products dot length I plus plus. For every product category available in the this dot products list, we'll set the observer map to the empty list. There are no observers yet. Whenever there is a customer who is interested in receiving updates for a particular product category, they can invoke the subscribe method on this e commerce site. Subscribe takes in two input arguments, the product category in which the customer is interested and an observer function. The observer function is essentially the callback function that will be called whenever there is a change in that corresponding product category. So we look up the observer map using this product and push this observer function to the end of the list of observers that we already have. Now, it's quite possible that a customer of this e commerce site might be interested in a product category for a short period of time, but then later is no longer interested because he or she has already bought that product and doesn't wish to receive notifications for that category. So, this means the subscriber is no longer interested in receiving notifications for a topic, which is why we expose an unsubscribe function on the e commerce website. Unsubscribe takes in two input arguments, the product and the observer function that has to be unsubscribed. We'll get access to all of the observer functions for this product category using the observer map. The variable observer functions will now have a list of all of the observers for this particular product category. We'll run a for loop through each observer function and check to see whether the observer function is equal to the observer function passed in as an input argument. If yes, we'll go ahead and run a splice operation on the list of observer functions to splice out that particular observer function, that is, remove it from the list. Unsubscribe will essentially get rid of the observer function so that it's no longer part of the list of observers that will receive notifications for this product category. We've written two methods that deal with the management of subscribers to the different product categories of this e commerce site. Now, let's move to the publisher end of things. So, whenever there is a change in a particular product category, we want to publish messages so that the interested subscribers receive the right notifications. And we'll do this using the publish method that you see here. The publish takes as an input argument the product category for which the message needs to be published and the actual contents of the message. We'll print out to the console log published message for product and the product category. Then we'll get a list of observer functions that correspond to this particular product category from the observer map. The observer functions list here will hold all of the observers who are interested in hearing about this particular product. So we'll run a for loop through this list of observer functions and then invoke each function and pass in the product and the message to the observer. This means every observer who's interested in a particular product will get the notification for that product. Now that we've implemented all pieces, all building blocks of the observer pattern, let's go ahead and instantiate an object of the e-commerce website class and let's see the observer pattern in action. Let's now also set up a bunch of different observers. We have the observer Alice. You can think of this function as representing the customer Alice on this e-commerce website. The observer Alice takes as an input argument the product in which Alice has expressed interest and the message, that is the notification for that product category. This is the observer function that Alice will use to subscribe to the different products on the e-commerce site. The body of the observer will simply print out to the console log received by Alice the message for this product. In exactly the same way, let's set up the observers For the other customers of this e-commerce site, there is the observer Bob corresponding to the customer Bob, and the structure is the same. Takes as an input argument the product and the message, and we'll print out to the console log received by Bob this product and this message. Go ahead and set up the observer function for Irene, the third customer for our e commerce site, and Julia, the fourth customer for our e commerce site. We'll just work with these four observers for now, and that'll allow us to see the entire pattern in action. In order to receive notifications for a particular product category, the customers have to subscribe to those products. I'm going to invoke the subscribe function on the e commerce website. The customer Alice is very interested in mobile phones and is looking to buy one and wants to receive all notifications for this category. So I invoke the subscribe function, pass in the product as mobile phones, and the observer function here is the observer Alice function that we had set up earlier. The code within the subscribe function will register the observer Alice as interested in the mobile phones category by adding this observer function to the list of observers in the observer map. Now, before we have any more observers subscribing to notifications, let's print out to the console log this e-commerce website object and take a look. We've written a bunch of code. Time to head over to Chrome and test this. Click through to the observer pattern and expand Chrome Developer Tools, and let's take a look at the object in our console log messages. The e-commerce website here has two properties, the observer map and the list of products. Let's expand this observer map and take a look. You can see that this object has an entry for each of the products on our e-commerce site, an entry for books, dog food, fashion, household items, and mobile phones. The values corresponding to each of these entries are the empty list for the first four categories: books, dog food, fashion, and household items. However, the list corresponding to the mobile phone entry has a single function within it. So far, we haven't set up any observers for the first four categories, but the mobile phones category does have an observer, the observer Alice, who subscribed to this category. If you expand the list that corresponds to mobile phones in this observer map, you'll see that there is one entry in the list. The function is the observer Alice function. So far, everything seems to be exactly as we expected it to be. If you expand the list of products here, you can see all of the product categories available on this e-commerce site. And if you expand the proto property of this e-commerce object, you can see all of the methods available. You can see the publish method to publish messages, subscribe method for the subscribers to subscribe to notifications for specific products, and the unsubscribe method to unsubscribe from notifications. Let's head back to the code here and try and publish a single message. E-commerce website dot publish, and I want to publish on the mobile phones topic. That is the topic for which we have a single subscriber, Alice. The content of the message simply says the iPhone 10 is now available. This is to indicate to all interested subscribers that this phone can now be bought on this site. Let's switch back to Chrome and hit refresh and take a look at the console log messages. And there you see it, our observer pattern in action. We first have the console log message indicating that we have a message that was published for the product mobile phones. And this particular message was received only by the observer Alice, the single subscriber to the mobile phones category. Let's test our observer pattern in a little more detail. I'm going to go back to the code and use the subscribe function to add the observer Irene as a subscriber to the same category, mobile phones. And I'll also have the e-commerce site publish a new message to this category. The Samsung S10 has sold out, indicating it's no longer available. Now let's go back and hit refresh, and you look at the console log messages, you'll see something interesting. Now, initially, when we published the first message, the only observer was Alice. So the first message is received only by Alice. The iPhone 10 is now available. Then we added another subscriber to the mobile phones category, that is the observer Irene, and the second message that is published is received by both Alice and Irene. Irene, as a customer, will not receive any notifications for messages that were published before she subscribed to the mobile phones category as a topic. She'll only receive messages that were sent out after she subscribes. Back to the code, I'm going to print out the contents of the e-commerce website to see if it's set up like I expect it to be. Back to Chrome, hit refresh and let's expand the e-commerce object and take a look at the current set of observers. The only observers that we have are for the mobile phones category, and there are two observers here, observer Alice and observer Irene. All of this looks good so far. Back to our code here, and I'm now going to add in some observers for a different product category. Both Irene and Julia are very interested in books, so they subscribe to the books topic on our e-commerce site. Once Irene and Julia have subscribed to the books category, I'm going to go ahead and publish a new message on this category. Books by Roald Dahl are now on sale. And I'll also log out to the console the current state of the e-commerce object. And if you hit refresh, you'll see our publisher subscriber model built using the observer works just fine. When we publish the message for the product books, it's received by the two subscribers who are interested, the customer Irene and the customer Julia. Both of them receive the notification for the books category. And if you expand the e-commerce website object here and take a look at the observer map, you'll see that we now have two observers for the book category, observer Irene and observer Julia. These are our newly added subscribers. And in the mobile phones category, we continue to have Alice and Irene as subscribers. Now, at some point, Irene might go ahead and buy a mobile phone and is no longer interested in product updates on mobile phones. So, Irene will go ahead and unsubscribe from the mobile phones category. So, e-commerce website.unsubscribe mobile phones and pass in observer Irene. This is the observer which we had used to previously subscribe. Irene has now unsubscribed from mobile phones, but she's still subscribed to books. Now I'm going to hit publish on two messages, one for the books category. Harry Potter books are now back in stock, and I'm going to publish another message for another category, that is mobile phones. Mobile accessories at a discount are now available. Now let's switch over to our Chrome web browser and hit refresh. Look at the console log messages at the very bottom here. Irene is still interested in books, so Irene as well as Julia received the notification for Harry Potter books. However, Irene was no longer interested in mobile phones. She unsubscribed from the mobile phones category. So the last message that was published for mobile phones, the mobile accessories message, is only received by Alice and not by Irene, since Irene is no longer subscribed. I'm curious about the current state of the e-commerce object, so I'm going to print it out to the console log. I want to take a look at the observers for the different categories here. So here is our e-commerce website object at the very bottom. I'm going to expand this and take a look at the observer map. You can see that now the books category still continues to have two observers, Irene as well as Julia, but the mobile phones category has just the one observer, Alice. Irene is no longer interested in mobile phones. She unsubscribed from this category. Now, it's quite possible that Irene is just tired of receiving all of these notifications. So, I'm going to head back to code and have Irene unsubscribe from the books category as well. After Irene unsubscribed from books, we'll publish a new message to the books category. New titles are available in travel, and we'll log the e-commerce website object to console log messages. Hit refresh on Chrome, and let's take a look at which subscribers received what messages. Note that the last message in the books category, new titles available in travel, was only received by Julia. Irene is no longer a subscriber to this category. She does not receive the message. Of all of the design patterns that we've worked with so far, the observer pattern is one that is the most familiar to JavaScript developers. And this is because JavaScript developers are used to dealing with event handlers. The entire event handling mechanism in JavaScript, no matter what library we use to wire up our event handlers, is based on the observer pattern. HTML elements on our web page fire events. Those are the publishers of events, and event handlers are the subscribers. Let's take a look at this example here where we'll see how event handling works in the context of the observer pattern. So we'll match the standard publisher subscriber model of the observer pattern to the event handling system. We'll use jQuery to wire up our event handlers just because it's so easy to work with, no other reason. You can set up event handlers using plain JavaScript as well. The pattern remains the same. Here is our HTML file. If you scroll down to the bottom here, you'll see that we have a number of buttons on our web page. There are 4 buttons here with different IDs. The first button with ID equal to asterisk, second with ID equal to dollar, third with ID equal to hash, and the fourth with ID equal to ampersand. Now, these are the buttons to which we'll wire up different types of event handlers, and we'll do this in jQuery observer pattern.js. As usual, we'll write all of our code within the document ready handler. Since we're focused on the observer pattern as it's implemented for event handlers, we are not really interested in what exactly the event handler does. Just to keep things interesting, we'll have our event handlers print out a random number of characters onto the console log. We'll use this function here, make random string, which takes as an input argument the character that we want printed out a random number of times. We'll first generate a random number between 0 and 100. We'll use math.random, multiply that by 100, and then call math.floor on the result. We'll then run a for loop this random number times, and for every iteration of the for loop, we'll append the character passed in as an input argument to this string variable and then finally return the string. Let me fire up the first event handler. There's nothing really special that you don't know here. Here I use the $sign to select the div with ID equal to asterisk, and I've added an on-click handler. How is this the observer pattern? Well, the div with ID equal to asterisk is the publisher. This publisher is capable of publishing messages on several different topics, and the topic in which our event handler, the subscriber, is interested is the click event. And this event handler function here, which takes as an input argument the event and prints out to the console log a random string of asterisk characters, that is the subscriber. Observe how all of the elements of the classic publisher subscriber model is present here in this event handler setup. And this publisher subscriber model, as you know, is a hallmark of the observer pattern. Let's click through to jQuery observer pattern.html, open up Chrome Developer Tools, and observe the console log messages while we click on the button with the asterisk sign. Let's see what exactly happens here in the observer pattern. When we click on the button, the click event is the topic on which a message is sent out by the publisher, that is the button itself. When a message is sent out on the click topic, the subscriber is called, which then prints out these random number of asterisk characters onto the console. And you can click on the button multiple times. Every click is a new message published to the click topic. Now, in the real world, you might have several different publishers which publish messages on the same topic. And that's true in the world of event handlers as well. Here I've wired up a subscriber, that is an event handler, to the button with ID $. Once again, our event handler subscriber is interested in receiving click events from this $publisher. So we've wired up a click event handler. On click, the subscriber will simply print out to the console log a random number of $characters. Let's go on and wire up 2 more event handlers. This event handler is on the element with ID equal to hash. This element is the publisher. This is a click event handler. Click is the topic, and the subscriber will print out to the console log a random number of hash characters whenever it receives a message from the publisher on the click topic. One more subscription to the publisher. This is the element with ID equal to ampersand. The topic is click, and the subscriber will print out to the console log the ampersand character a random number of times each time a message is received on this topic. Let's quickly satisfy ourselves that all of these event handlers, or rather our publishers and subscribers on the click topic, are working as expected. You can click on the different buttons, and on the console logs, you'll see the different characters printed out any number of times. Number of times range from 0 to 100. So far in our code, publishers and subscribers are 1:1. We have 4 different publishers, that are our 4 buttons, and we have an event handler for each of these buttons. 4 different event handlers, 4 subscribers. In the real world though, there can be any number of publishers, any number of subscribers, and publishers can publish messages on any number of topics. Let's see that in action here. When we wire up this event handler here, I'm using the $selector to select all divs that have the button class applied. This selector will select all four div buttons on our page, and we'll add an additional subscriber on the click topic. And this subscriber will simply print out to screen, click on button and the text associated with that button. Every publisher on this page, that is every button, has two subscribers on the click topic. Let's go ahead and run our code, for which all we have to do is hit refresh on this page. Now I'm going to click on one of these buttons here, and this should send the click event to two interested subscribers. One subscriber prints out the asterisk character a random number of times to the console log. The second subscriber tells us that we've clicked on button asterisk. Let's now click on the dollar button, which is our second publisher here, and you can see that the two subscribers to this publisher on the click topic have been notified. The first subscriber, our first event handler, prints out the dollar sign a random number of times to the console log. The second one tells us that we've clicked on the button dollar. And you can try this with all of the buttons, all of the publishers that we have here, and you'll get the same result. Each button has two subscribers for the click topic. In the real world, a publisher does not just publish messages on a single topic. A single publisher might publish messages on multiple topics, and that's true in event handling as well. Here, I have wired up an event handler to the mouse down event. The fact that this event handler is on the mouse down event, it means that this subscriber, the event handler, has subscribed to a different topic. To all four publishers on a different topic, the topic is mouse down. And once this event handler is executed, our subscriber will simply change the CSS properties of the button which was clicked on. We'll change the background color to yellow and the color of the text to black. So with all of the wiring up that we've done so far, we have multiple publishers, multiple subscribers. We've also seen an example of multiple topics. Back to the Chrome browser here and hit refresh. And now let's go and click on individual buttons here. Each time we click on a button, the click event as well as the mouse down event is fired. The click event or the click topic has two subscribers. The first one prints to the console log a random number of asterisk symbols. The second subscriber prints out click on button asterisk. And the third subscriber, which is on a different topic, the mouse down topic, changes the color of this button to yellow. Now, in our previous demo, we saw how the observer pattern exists in the event handling of JavaScript, and we worked with jQuery event handlers for the click event and the mouse down event. And we also know from our general experience in JavaScript that HTML elements fire a number of standard event types. Click and mouse down are amongst them, but we also have the mouse out, mouse enter, mouse leave, and key events. But if you're working with jQuery, you also have the ability to have your document, your window, or any other element fire custom events that you can listen on. And that's exactly what we'll see here in this demo. Triggering and handling custom events in jQuery. Let's take a look at the HTML file for this demo. As you see, it's pretty straightforward. We have a number of CSS classes and we have the HTML structure of the page here at the bottom. You can see that there are four divs here which have the CSS class button applied. The first div has ID equal to mobile phones, and the text content also says mobile phones. Then we have the books div with ID equal to books, household items div with ID equal to household items, and the fashion div with ID equal to fashion. As you can see, these are product categories on an e-commerce site. These buttons will serve as our publishers, and these publishers will fire custom events to notify subscribers whenever there is a notification corresponding to one of these categories. These product categories are the topics in our publisher subscriber setup. Let's get coding, for which we'll switch over to the jQuery custom event observer pattern.js file. And as usual, we'll write all of our code within the document ready handler. Now I'm going to set up a little helper function here that will allow me to generate the message that I want for my notification at random. The function is called getRandomMessage, and I've initialized a list of 5 random messages. Big sale on, new items available, clearance sale running out soon, and back in stock. For every invocation of this function, I'll select one of these messages at random by generating a random message index. Math.random multiplied by 5 messages and math.floor of that. And I'll return the message which exists at that random index. For each product category, I have subscribers who are interested in receiving messages or notifications about that category. I'll represent each of these customers as subscribers or observers. We have the function that is the observer Alice, and the input argument here to this function is the event that was triggered to invoke this observer and the message that this observer receives. Within the observer, I'll print out to the console log the event type that was received by Alice and the message as well. I'll also print out to the console log the entire event object so that we can examine what it contains. I'll now set up observer functions for the other customers of this e-commerce website. I have the observer Bob here, and the structure of this observer function is the same as the previous observer. Along with Alice and Bob, we have a third customer for this e-commerce site, and that customer subscriber is represented using observer Irene. The format of the observer is the same. I'll add one last observer here. This is the observer Julia. Now, the next step is to wire up these observers to the custom events that jQuery fires. I'm going to fire all of the custom events on the document object. So my listeners will also be on the document object. Selecting the document object in jQuery is straightforward. I use dollar and in parentheses document, and then I invoke the on function to set up an observer for a custom event. I select the document, invoke the on function, and the custom event that I'm listening to is the mobile phones category. And there are two observers that I've wired up here, observer Alice and observer Julia. Both of them are interested in mobile phones. Let's wire up some more observers. I select the document once again, invoke the on function, and observer Bob and observer Julia are interested in household items. Let me add in three more observers here, this time for the books category. So I use dollar document to select the document, invoke the on method, and have wired up observer Irene, Alice, and Bob to listen on the books category. The event type specified here is books. And finally, I'm going to have one listener on the document for the custom event type fashion. This is observer Irene. Now that we have set up all of our subscribers for the different product categories that are topics, let's wire up our publishers. I'm going to wire up a click handler on the div with ID mobile phones. And when this div is clicked on, I'm going to trigger a custom event. $document.trigger is how you trigger a custom event in jQuery. The custom event type is mobile phones, and the message that I'm going to send as a part of this custom event is one of the random messages that I had set up earlier. Whenever you click on this button, the custom event mobile phones will be triggered, and the corresponding listeners or observers for this event will be notified. I'll do a similar wiring up of the other events on this page as well. I'll wire up a click event handler to the button with ID books, and when this event handler fires, it'll trigger a custom event. The event type is books, and the message associated with the custom event is a message we pick at random using getRandomMessage. Let's do the same thing for household items as well. On clicking the button, we'll trigger the custom event on the document. The event type is household items. One more button to wire up. When we click on the fashion button, we'll trigger on the document object the custom event fashion and send a random message to all of the observers of the fashion category. Let's head over to Chrome and see how custom event handlers work in jQuery. I'm first going to click on the button which says mobile phones. This will trigger the mobile phones event, and you can see that the mobile phones event has two listeners, observer Alice and observer Julia. And if you take a look at the console messages, you can see that new items available. That is the message that was picked at random. That is the message that Alice and Julia have received. We've also printed out to the console log the event object received by each of these observers. And you can see that this is of type jQuery.event, and it has a number of properties and methods giving you additional information about the event that was received by the observer. If you scroll down a little bit, you'll see that the event has a property called type, which gives you the type of event that was received by this listener. The type here is mobile phones. There's also a timestamp associated with each event indicating when that event was triggered. We're more interested in the observer pattern implemented using custom events in jQuery. I'm going to click on the books button here, and you can see that we have three listeners here for this books event: Irene, Alice, and Bob. And if you take a look at the console logs, you can see that this books custom event, along with the random message that we picked, was received by exactly these three listeners: Irene, Alice, and Bob. And the random message was back in stock. Let's go ahead and click on another button here to send out another message. And the button that we've picked here says household items. This has two observers, Bob and Julia. And you can see from the console log messages that the clearance sale message was received by both Bob and Julia. There's a cleaner way in which we can wire up our event handlers to trigger custom events. So I'm going to comment out all of this event handling code, starting from the mobile phones down to the fashion buttons. And I'm going to set up some new code for event handling. I'm going to select all of the buttons on my web page, that is all divs with the button CSS class applied, and wire up an event handler to each button. When the user clicks on any of these buttons, I'm going to trigger a custom event on the document. These parts are exactly what we saw previously. However, this custom event that we have to trigger has a different event type based on the button that we click on. Now, in the HTML of our page, if you look at the ID attribute for each of our buttons, they correspond to the different product categories or the topics for our publisher subscriber model. The ID of each of these buttons also correspond to the different event types that we use for the custom event that we trigger on the document object. So when I call $document.trigger, I'll select the current event target, that is the button on which the actual click was received, and extract the value of the ID attribute. And that will be the product category or the topic, which will serve as the event type in this custom event. Back to our browser to see whether this works, let's click on the mobile phones button, and you can see that messages were received by Alice and Julia. These are the two subscribers to the mobile phones category. Let's click on books. Books has three subscribers: Irene, Alice, and Bob, and all three of them receive notifications or messages saying new items available. Back to our code. For a successful publisher subscriber setup, we need for a way to have subscribers unsubscribe from topics. And this is possible in jQuery custom events using the off function. So we select the document using $document, invoke the off method, and observer Alice has now unsubscribed from the mobile phone's topic or category. Back to our browser, if you hit refresh and click on the mobile phones button to trigger the message for the mobile phones category, this will now only be received by Julia. Alice has unsubscribed, she's no longer a subscriber. Let's go back to our code here, and observer Irene is no longer interested in books. I select the document and invoke the off method and turn off observer Irene. Irene is now no longer subscribed to the books category. Let's switch back to Chrome and hit refresh and see how things change here. I'm going to click on the books button and notice that messages are now received by Alice and Bob about the big sale that is on in the books category, but Irene does not receive a message. Thus, it's not just regular event handlers that jQuery allows us to work with. We can set up our own custom event handlers for custom events. A behavioral design pattern that you might have encountered almost as soon as you started learning programming is the iterator pattern. Of course, at that point in time, you may not have known that this is a specific design pattern meant for a specific use case. You would have just used the functionality the iterator provided without thinking about it. So, what is the iterator pattern? Well, you've run for loops, haven't you? Well, for loops allow you to iterate over the elements in a collection, iterate over the elements in an array in JavaScript, and this is only possible because JavaScript arrays implement the iterator pattern. The whole objective of the iterator design pattern is to allow you to access the elements within your collection in a sequential manner. So if your collection has some kind of order like arrays do, then your elements will be accessed in that order. That is the correct sequence. But you might have other objects where there is no inherent ordering. In that case, the iterator will simply allow you to access the elements of that collection in any order. The iterator pattern does not just work with JavaScript arrays and objects. You can apply the iterator to iterate over your own custom collection. The iterator pattern basically says you should be able to access the elements of your collection without knowing how the collection is implemented. The iterator pattern helps you access elements sequentially without exposing the underlying representation of elements. When you use the iterator pattern, you've no idea how the collection is actually implemented, how the elements are organized. You just use the iterator, and that will allow you to iterate over elements in the same way, no matter what kind of collection you're working with. The name of this design pattern, the iterator pattern, makes it very obvious that it's meant for iteration. It's a classic way of accessing elements in a collection. It allows the same code to iterate over many different types of collections. Basically, the interface of the iterator remains the same. Whether your collection is a tuple, whether it's a set, whether it's a dictionary, that does not matter. The same code for iteration will work across collections. This is the objective of using the iterator pattern. Your for loop does not change whether you're iterating over a set or a tuple or a list. That's because of the power of the iterator pattern. The basic idea behind the iterator pattern is that it separates the implementation of the container being your collection, from the mechanism of iterating over the contents of your container. So, how you iterate should be different from what exactly the collection is about, how the collection is represented. When you use the iterator pattern over your collection, whether the collection is a list or a map of objects, you may have several different implementations of how traversal occurs. And each of these implementations might use a different strategy. For example, you might have an iterator over a list, which follows the sequential strategy. An iterator over a map can access the elements at random. You might have an iterator that traverses a tree structure in a recursive manner. No matter how your collection or aggregation is set up, the code which performs the actual iteration, that is, the iterator, should not bloat the code for the original collection. The original collection should only be a collection. Solving for how that collection should be traversed should be the domain of the iterator pattern implementation. So, when you implement the iterator pattern in your code, the idea is that you take the responsibility for traversing the collection out of the aggregate or the collection object and put it in a separate object that implements the iterator pattern. The iterator abstraction is a fundamental concept in the idea of generic programming. Generic programming is a kind of programming methodology where you separate the algorithm from the data structure. So, the changes that you make to your algorithm should be independent of the changes that you make to your data structure. They should be loosely coupled and have a common interface through which they communicate and interact. Generic programming has several advantages. It promotes component based development, decouples responsibilities, the algorithm is separate from the data structure, and lowers configuration management. Let's see a visual representation of how the iterator pattern works. You have a client, and this client wants to access all of the elements in a collection. Now, the client has no idea what kind of collection it is. As far as the client is concerned, it could be a list collection or a map collection, a tuple, a set, or any other kind of collection. The client should be completely abstracted from the implementation details of the collection. The client should be able to iterate over the collection even though it doesn't know what the collection is about. So, what you need is some kind of traversal abstraction, some abstraction that allows you to traverse over the elements in a list, a map, a set, a tuple. This traversal abstraction may need to implement a bunch of methods. The traversal abstraction may implement a method called first. which resets the iteration to the first element in the sequence. It may also implement a method called next, which allows you to access the next element in the sequence at any point in time. And it may also have a method called is done, indicating that the iteration is complete, you've reached the last element in the sequence, you're done. Your client should always work with all collections using this traversal abstraction. So each collection, whether it's a list collection, a map collection, or a tuple, should implement the traversal abstraction interface. We should have a list traversal and a map traversal abstraction. The use of this higher level traversal abstraction will allow clients to work with all kinds of collections using the same set of methods. In this demo, we'll study and implement the iterator design pattern in JavaScript. The iterator pattern allows users or clients to access the elements of an aggregate, which is typically a collection of some sort, in a sequential manner. And accessing these elements sequentially should not expose the client to the underlying structure or the underlying representation of the data. In this demo here, we'll set up our own implementation of the iterator pattern. And in order to implement the iterator design pattern, we'll harness another design pattern that we've studied before, the mixin pattern. We'll use the underscore dot extend function from the underscore dot JS library. The HTML file for this demo is very straightforward. It simply references the underscore dot JS file in the current working directory. We'll write all of our code for our iterator in the iterator pattern.js file. So let's switch over to that file and start coding. I'm going to set up a mixin called iterator, which exposes all of the basic functionality of an iterator. This mixin will serve as an interface or a base object, and collections and other aggregates can extend this mixin in order to allow clients to iterate over the elements that they contain. When you're iterating over the elements of a collection, you need a way to reset your iterator, so you start once again at the first element. I'm going to implement a reset function here, which sets this dot index equal to 0. There is an assumption made by the iterator mixin here that you should be aware of. This iterator assumes that whatever object extends this iterator mixin has a property called index, which points to the index of the element that is currently being accessed. And this is the index that we set to 0 in the reset function of this iterator mixin. I'll define the second function for my iterator object here. This is the hasNext function. This function will return true if there are other elements in the sequence that haven't been accessed yet. It will return false if we've reached the last element in the sequence and there are no more elements. In our case, we'll just check to see whether this dot index is less than this dot items dot length. Now, here is another assumption made by this iterator mixin. This iterator assumes that all of the items in the collection are stored in a property called items in the current object. This dot items is essentially a list of elements that make up this collection. As long as the current value of the index property is less than the items dot length property, we know that there are more items to be iterated over. The next function I'm going to define here is called next. Next is the function that actually accesses the next element in the sequence. Now, the next function needs to perform a bunch of checks. It will first check to see whether there are other elements in the sequence yet to be iterated over. So, if this dot hasNext returns false, we'll throw an error saying no more items. If there are elements in the collection that haven't been accessed, we'll access the current item at the current index. We look up the item at the current index in the items list and store it in the variable current item. We then increment the index by 1 using this dot index plus plus, so the index value now points to the next element in the sequence that will be accessed after this one. And then we go ahead and return the current item that we just accessed. There are a number of other helper methods that you could add to the iterator function. I'm going to add one more here called first. First is a function that allows me to access the first element in the sequence directly. So what I need to do here is to reset the index by invoking this dot reset and then return this dot next. This dot reset will set the current index value to 0, and then this dot next will return the element at index 0 from our collection. Now you could choose to add additional functionality to an iterator as I'm going to do here. I'm going to expose a method called each, which allows me to iterate over all elements in a sequence and apply a function to each and every element. So each takes a single input argument, that is the callback function that is applied to every element in my sequence. In the body of this each function, I'll run a for loop var item is equal to this dot first. This will initialize the variable item to the first element in our collection. We then check to see whether there are more elements in the collection using this dot has next. If this is true, then we move to the next item in the list. Item is equal to this dot next. This set of statements in our for loop will allow us to sequentially access every item in our collection, and we apply the callback function to each item. We'll come out of the for loop when this dot has next returns false, and that's when we'll be at the last item in our list. We'll need to call the callback function one last time so that it's applied to the last item in the list, and we do that outside of the for loop. Now that we have defined all functions within this iterator mixin object, let's now set up classes to represent collections, and we'll then have these objects extend the iterator mixin to allow us to iterate over the elements in that collection. We'll start off with a collection of students. I've defined an ES6 class called students, and within the constructor, I initialize the two properties that my iterator mixin expects. I initialize this dot index to be equal to 0, and this dot items I've set to be the empty list. I also expose a method called add student, which takes as an input argument the name of the student, and this student will now be added to my list of items using this dot items dot push name. When we instantiate an object of this students class, we won't be able to iterate over the elements of the students collection till we have the students class extend the iterator mixin. In order to include the functionality of the iterator mixin in my students object, I use underscore dot extend and pass in students dot prototype and the iterator object. So all of the functionality in the iterator will now become a part of the students class and will be present in every students object that we instantiate. Let's now go ahead and instantiate a new object of type students and assign it to the variable students. And I'm going to print this object out to the console log to make sure that it has all of the iterator's properties. Let's head over to Chrome and click through to iterator pattern.html and open up Chrome browser tools where we can see the students object that we had instantiated. You can see that the index property is set to 0 and the items list is the empty list. And if you expand the proto property of this students list, you'll see all of the functionality that it gets from the iterator mixin. We have the each function, which takes in a callback function and applies it to each element in our list. We have the first function, the has next, next, and the reset. Now that we know that the students aggregate or collection exposes an iterator interface, let's use the iterator to access the names of students in our students collection. We first need to add in a few students though. So I'm going to invoke students.addStudent and add in the names of 5 students: Elise, Fiona, Harold, Jeremy, and Kim. The first method that I invoke on the students collection is students dot first that will allow me to access the first element to the list. That's what is returned here. I'm going to print the first element out to the console log, and let's head over to Chrome and hit refresh, and there you see it. The first element in the students collection is Elise, printed out to the console log messages. We don't know how the collection is actually implemented when we invoke the first function, but we get access to the first element anyway. If you access and expand the items in the student collection, you can see the 5 student names that we've just added. And Elise is the first name in that list, which is what was returned when we accessed students.first. If you recall the code for students.first, we reset the index using this dot reset, and then we return this dot next. And if you take a look at the code for the this dot next function, we access the item at the current index and then increment index by 1 by calling this dot index plus plus. The next function actually increments the current index. So index now is equal to 1 as you can see in the students object. Back to our code here, after accessing the first element, I'm going to check students.has next. I'm going to check to see whether there are other elements remaining to be iterated over. And I'm then going to call students.next to access the next element in the sequence. Let's see how this plays out. I'm going to hit refresh here. First, Elise, the first element will be printed out to screen. Has next is true. And then we call students.next to access the next element, which is Fiona. I'll now go back to our code here and do this a couple of more times. Each time I'll check to see students.has next whether it returns true or false, but without checking the return value, I'm just going to call students.next. So at this point, our code accesses the first element using students.first, and then we invoke the next function 4 times. And we have just a total of 5 elements in our list. This should be interesting. Let's head over to Chrome and hit refresh. The first student in our list is Elise, that is right, has next is true, then Fiona, has next is still true, then Harold, has next is still true, then Jeremy, has next is true, and then we have Kim. However, if you remember in the list of students that we've added, Kim is the very last student. There are no elements after Kim. So let's go back to our code here and check for has next to see whether it's true and then call next anyway, even though there are no elements left. Let's see what happens. If you run this code on the browser, you'll immediately see that after a few successful console log messages for the elements in the list, we'll receive an error. This is an uncaught error that says no more items. We know that Kim is the last element in this list, so this error makes sense, but where did it come from? Remember our next method here? If not this dot has next, that is, there are no more elements to iterate over, our index value has reached the very last position in our collection, we throw this error within our next method. Clearly, this last access is an error. We need to comment out this bit of code. The one thing that you need to take away is always check to see whether has next is true before you access the next element in the sequence. That's generally how it's done. I'll now go to Chrome and hit refresh and make sure that this error has disappeared. I want to make sure that my code runs fine before I make additional changes. The error has disappeared. We're only accessing up till the last element in that list. Now let's go back and reset our index so that we go back to the first element in the list. And this we can do by calling students.reset. And after having reset our students collection to start iteration once again at the first element, I'm going to call students.next. Let's see if we start over from the beginning. Hit refresh and take a look at the console messages. Once we've reset our index using students.reset, when we invoke the next method, we go back to the first student in the list, Elise. Back to our code and let's invoke students.next 4 more times. So I've called next a total of 5 times. This should print out all 5 elements in my list. So after the reset, we should start with the student Elise and go all the way up to the student Kim, and that's exactly what we see here in the logs. Reset allows us to reset our iteration. I'm now going to invoke the dot each function to print out the names of each of our students. Dot each takes in a callback function, and this callback function takes in a single input argument which represents the element of the collection that we are iterating over. In our case, I've kept the callback very simple. Within the callback, I simply print out to the console log 3 asterisks and in each and the name of the current element. Back to the Chrome browser in order to run this code and observe at the very bottom here, we have a list of all of the student names printed out using our callback function. We know the console log messages are from within the callback function applied to each element in our collection because of the presence of the 3 asterisks before each student name. Back to our code and let's now see how the same iterator mixin can be used to extend another collection or another aggregate object. And this is a class which contains a list of cities. Within the constructor for this class, I've initialized the index property to 0. Remember, the iterator expects that we have a property named index and a property named items. I've initialized this dot items to a list of cities. The cities here are New York, Boston, San Diego, San Francisco, and Austin. If you want to be able to iterate over this collection of cities, we can use underscore dot extend and extend cities dot prototype with all of the functions available in the iterator mixin. And that's all there is to it. Now, when we instantiate a new cities object, that is a collection of cities, we can now invoke iterator methods on this. So I'm going to go ahead and invoke cities.next and print it out to the console log that will access the first element. And then I'm going to invoke cities.next one more time to access the first two elements in my collection in sequence. Hit refresh on Chrome, and here at the bottom, you can see New York and Boston. These are the first two cities in our collection of cities. Now we can invoke the dot each function on our collection of cities by calling cities dot each. When you use the dot each function to iterate over all of the elements in your collection, it doesn't matter what the last accessed element was. With dot each, you always start off at the beginning. The callback function that we pass into dot each is the same as before, a function which takes in the name of a city and prints it out to the console log. Back to Chrome and hit refresh, and there you can see it. We start off with New York once again when we invoke the dot each function on cities. We go New York, Boston, San Diego, San Francisco, and Austin. We iterated over all of the cities, applied the callback function which printed out the names of the cities to the console log messages. In the previous demo, we saw how we could build our own custom iterator using mixins, and this mixin could be used to add functionality to other collections. Now, in this demo, we'll see an implementation of the iterator within the jQuery library. So make sure you have jQuery 3.4.1.js in your current working directory. Let's take a look at the HTML code for this particular demo. If you scroll down to the bottom here, you'll see that I have an unordered list of items that I've set up within a UL tag. Each list item represents a city, and these cities belong to different countries. The first four cities here are New York, Boston, Dallas, and Memphis, and these four cities have the country attribute set to USA. The next three cities are Bangalore, Delhi, and Mumbai, and these have the country attribute set to India. They also have a CSS class IND applied to these elements. Keep this in mind, and let's switch over to the JS file jQuery iterator pattern.js, and let's start coding. As usual, we'll write all of our code within the document ready event handler. Before we write any more code here, let's just see what our HTML page looks like on the browser. The header says jQuery iterator pattern, and we have 7 items in our unordered list. If you want to see the HTML structure, you can select an element, hit right click, and choose the inspect option, and this will bring up Chrome Developer Tools. You can see that all 7 of our list items are here specified within li HTML tags. Back to our code, and I'm now going to use the iterator available in jQuery. jQuery allows us to access a $.each method that allows us to iterate over collections of items. Here, $.each will iterate over every element in this list that we have specified here. This list contains 3 cities: Melbourne, Sydney, and Perth. All 3 are cities in Australia. The first input argument to this .each method is the collection over which we want to iterate. The second input argument is the function that we want to call on every item in the collection over which we iterate. This function takes in 2 input arguments: the index of the current element in the collection and the actual element, which are stored in the variable city. This is a function that will be invoked for every element in my collection, and for each element I want to append an li tag where the text for that tag is the name of the city. I'll add in the attribute which says country is equal to Australia, and I'll append this li tag to the ul tag which already exists on my HTML page. But there is a slight twist here. I don't want this list item to be added in right away, but I want it to be done after 4 seconds, which is why the function that appends this list item to my unordered list, I've passed to a set timeout function so that it'll execute after 4 seconds. So if we now go to Chrome and hit refresh, for 4 seconds, the original list will be displayed. And then finally, the last three elements of the list will be appended. Melbourne, City, and Perth, three LI elements have been appended to our original unordered list. If you look at the HTML for the list items that were newly added, you can see that the country attribute is set to Australia. Back to our code here, we've seen how to use the dot each iterator in jQuery to iterate over a hard-coded list of items, and we saw that this worked just fine. Now let's see another example of this each functionality, the iterator, but this time I want to iterate over items that I've selected from my HTML page. I want to select all list items, which I do using dollar and specifying the li tag within dollar. And I'm going to run this function over every list item that I have selected. Within this function, I'm going to execute another function on a timeout. Let's leave the timeout bit for a second and let's take a look at what we want to execute. I'll access the value for the country attribute for the current object over which we are iterating, that is the list item. And then I'll also access the current text using $this.text. Once I have the country and the current text, I'm going to update the text of the current list item to be current text dash country. So I'm going to append the country to every item in my list. I'm going to execute this function on a timeout. I want this function to run 5 seconds after we've selected all of the list items. When you hit refresh, what you'll see first are the original 7 items in our list: New York, Boston, Dallas, Memphis, Bangalore, and Delhi. Then, after about 4 seconds, we'll see the results of the first dot each iterator, which will add Melbourne, City, and Perth to this unordered list. And after about another second, you'll find that the first 7 items have been appended with the name of the country. This is because of our second dot each iteration, which selected all of the list items and applied a function to every list item to append the name of the country to that item. But why weren't Melbourne, Sydney, and Perth selected? Well, remember that Melbourne, Sydney, and Perth were added after a timeout of 4 seconds. When the code for $li dot each, the selection of the list items and the iteration over them was executed, there were only 7 items in that list. At the time the li elements, that is, the list items were selected using $li, there were just 7 elements, and those 7 elements had their country appended to the city name. Let's see one last example of iteration using jQuery. This time I use the dollar selection to select all list items which have the CSS class ind applied, li.ind. These will be all list items which display the names of cities that are located in India. And for each of these list items, I'm going to add a CSS class to highlight those cities. And I want these list items to be highlighted after 10 seconds. So I'm going to cause this code to execute after a timeout of 10 seconds. Onward to Chrome, and when we hit refresh, the first 7 cities that we had on our web page will be first displayed. Then we'll append 3 cities: Melbourne, Sydney, and Perth. This happens after a timeout of 4 seconds, and after an additional second, I append the name of the country to the first 7 list items. And finally, after a few more seconds, all of the countries that are located in India have been highlighted. The highlighter has increased their font size and they are now displayed in the red color. In this course, we began our exploration of behavioral patterns in JavaScript, specifically the observer pattern for communication and the iterator pattern to work with collections. In addition, we also covered the implementation details of these patterns, such as the use of publishers and subscribers to implement the observer pattern for sending and receiving messages. We also triggered custom events in jQuery with the use of the observer pattern and then moved on to understanding the iterator pattern using iterators as mixins. We rounded out the course with the implementation of iteration over elements in a collection and explored the use of iterators in jQuery. At this point, you possess the knowledge needed to correctly identify situations that call for the use of some powerful and popular behavioral patterns in JavaScript, such as the observer pattern for communication and the iterator pattern to work with collections. You are now set up to explore other behavioral design patterns in more detail, such as the mediator, state, and command design patterns.